it's not going to be, it'll be a waste of time to try to print out every single item in this list, right? Rather, we use something called a for loop, and it does something called iteration. So iteration essentially just means that we are taking every single item in this list and applying some sort of function to it. That's what a for loop does. So let's define our for loop with for. Now, remember how I said A and B, right? Our A can be called anything. A just represents an item in the list. So let's just say for fruit. For fruit in fruits. What we're asking this for loop is to do is say, hey, we're taking every single item in this list and doing something to it. So we're taking every single fruit, and this can be anything. It could be A, just like how we define variables. It could be B. It could be X, Y, Z. It could literally be anything. But just so that we understand what's going on, just to keep it in the context of what we're doing, we can just call it fruit. So we're saying for every single fruit in this list of fruits, do something to it. Okay, so in this case, let's just see what happens when we say print fruit. So for every fruit in this list fruits, print that fruit. Let's see what happens. Prints out apple, banana, cherry, and pear. This is something called iteration. This is an example of a control flow that does iteration. So iteration, again, is taking each item in the list and applying some sort of function to this. In this case, we're doing the print function, but of course, another neat example of a control flow and for loops would be, let's just say we have a variable A, and let's actually create a string called. Let's just type in some random letters in this string. Okay, this is completely random. And let's just say for letter in A. What we essentially have done here is we're saying for every letter, so you know how we have lists, right? We can apply the same for loop on characters. Okay, so what we're going to be doing here is by saying for letter in A, print out each letter within this string is what we're telling it to do. So this is control flow within strings. So these control structures for loop can be done in the context of strings and in complex data structures like lists. So let's see what happens when we do for letter in A, print letter. Okay, let's see what happens. So an extremely long list gets printed out, but as you can see, it prints each individual character in this large string. That's what it does. We've stored the string in variable A, and then for each character in this string, we print out that character. So this is an example of control flow within strings. Okay. So now let's do something. Let's try to do something where we implement if-else statements in for loops. Okay, let's get back to the example where we have fruits. So we have our example fruits here. Okay. Let me just quickly do this. And so let's just forget about all this stuff. Just focus completely on the fruits variable that stores the list. So let's create a for loop. Let's say for fruit in the variable, or sorry, in the list fruits, if X is equivalent to banana. Okay. Print X. Now this might seem counterintuitive. Well, why don't you just print banana once, right? Like, what's kind of the point of that? Well, if we, in computer science, in computer science, we usually have large lists of binary, or we're going to have like a huge list with just zeros and ones. So if you don't know what binary is, it's just essentially a message. It's just kind of the language of like machine science, like computer science, and it essentially this is part of a bit. So it essentially takes inputs of zeros and ones and converts that into instructions for the computer to learn. So imagine having like thousands and thousands of just ones and zeros. So if we were to just say for I in binary, okay, if x is equivalent to 1, right, print x. So for all the instances in which sorry, not x, I. So for all the instances in which I equals equal to 1. So in this case, I will be equal to 0, then I equals to 1, then I equals to 0, then I equals to 0, then I equals to 1. So if we print all the instances in which I equals to 1, then we'll be able to do things with that. So we'll be able to know how many ones have been printed to the console. So that's a very useful application. So back to the fruits example, right? So for f in fruits, right? If I is equivalent to banana, so what we're doing is this is actually the most common example of why we use for statements in the first place. So instead of like trying to print out or like do something to every single, well, we are doing something to every single item in this list. So this is an example of iteration, but in the context of if-else statements. In our case, we are applying a function to each of these, and that function is this if-else statement. So what we're essentially telling the computer to do is cycle through each individual term in this list, and if that particular term in that list is compatible with what our condition is, then we print that value. So we're saying what the program is doing is we're saying, so check apple first. Is apple equivalent to banana? Since it's not, we don't print x. Then the program moves on to banana. Is banana equivalent to banana? Since it is, it'll print x. Okay. Then it'll check cherry. Is cherry equivalent to banana? Since it's not, we don't print x. Okay. Oh, sorry, I. And we check pear. Is pear equivalent to banana? It's not, so we don't print I. So in this case, banana was only printed once. Oh, shoot. Let's try to run this code. So sorry, we changed these F's to I's to F's because. So now, if we run it, banana only gets printed once. Okay? If I had banana again, my list somewhere, it would get printed twice. Now, there's an interesting statement we use in for loops that contain if-else statements. Okay, let's see what happens. So let's call the statement break, and let's see what happens. We have banana 2 times in our list, right? The word banana is located 2 times in our list. Let's see what happens. Oh, see, nothing gets printed. Let's see what happened. Okay. So let's look what we've done here, right? Now we look at the result. Why did it print apple? So now let me explain what the break statement does. So you know how we tell the program to iterate through each and every single item in this list to check if it satisfies our condition that we've expressed here, right? So break is actually using if-else statements, and it tells our program once this condition has been satisfied, stop iterating through the list. So don't go any further. Break is exactly what it means. Don't go any further, and I'll tell you guys what I mean. It iterates first, so that whenever iteration occurs in a list, the first item of the list is checked all the way, and it goes from left to right. So the first item is checked, then the second item is checked, and the third item is checked, right? So we start with apple. Since apple doesn't meet our condition, nothing happens. We move on to here. Since banana is equivalent to banana, we're telling the program, so now that the condition is satisfied, don't go any further. Don't check if cherry is equal to banana or pear is equal to banana. So it just stops. And that's why only apple was printed. Okay? So the opposite of break, essentially, is just continue. So if we do continue, the program will just run like normal. So it'll just print every single thing after that. So what we're telling the code is, if f equals to banana, ignore that item in the list and go through, proceed. When we say break, we're telling the code, if the condition is met, if this condition is met, stop the program, don't do anything, is what we're saying. Okay? Again, so when we type in continue essentially tells the program, perform this function on every single item except banana. So continue just tells Python, run the program as normal, except for banana. So yeah, that's kind of where we're at with break and continue. Okay, so now we have a really interesting thing, right? We don't actually need lists to run our for our for loops. Let's check an example of a for loop that doesn't really need a list. So when we're iterating through things, right? We have a function called range, and it takes input of A and B, and C is actually another. Again, by C, I'm saying A, B, and C are all numbers, integers specifically, or actually they could be any number, and C is actually an optional argument. So some arguments in a function can be optional, and they're just used to specify. If you don't specify an optional argument in Python, the program regards it as a default. Tweaks all the settings for default. So let's just see what I mean here. Range is a function that produces increments of 1 from any two numbers. What I mean by that is, if we have range of 1 through 5, and we store it in A, the function range converts these two numbers into a list of numbers between those two given numbers. So range of 1 through 5 is actually a list of numbers from 1 through 5. So instead of defining a large, so let's just say our list should comprise of numbers between 1 and 1,000, right? So instead of typing in 1, then 2, then 3, then 4, and then it's going to take a lot of time before you get to 1,000, right? Instead of doing that, we can actually call upon the range function to do this for us. So let's just say we want a list of from 1 to 1,000. Okay? And so what this does is the data that is stored to the variable A is just a list of numbers from 1 through 1,000. So the list is essentially going to look something like this. It'll be 1, 2, 3, 4, 5, all the way to 1,000. Now, when I told you guys about the A, B, and C arguments, the C argument is actually an optional argument, and it takes inputs of how the increment, how you should add on to each increment. And what I mean is this: if we have an increment of 2, so the default is 1. By 1, I just mean that the list will be 1, and then 1 will be added to it. So 2, then 1 is added to the previous number. 3, which is you add 1 to the previous number. 4, you add 1 to the previous number. 5. So the increment value is by 1. Now suppose I define the increment value to be 2. Okay, so now the list that is stored in the variable A will go something like this: 1, then 3, then 5, then 7, then 9. So just to prove this, let's check out. Let's just do it from 1 through 5. So let's do 1 through 7 in increments of 2. Let's see what happens. So let's print A. So it produces a list of numbers. Oh yeah, I forgot to tell you guys. When it says 1 through 7, it's actually not inclusive of the last number that you input in there. So again, without this optional argument, if we do range of from 1 through 5, let's see what happens. Oh, sorry, let's print out A. Okay, so if we print out A, it will only produce a list of the numbers 1 through 4, but 5 is actually is excluded because it only takes the number before the last number that you inputted. Okay. Similarly, how we do increments. So let's just do from 1 through 10 of increments 2. Let's see what happens when we print A now. Now it produces a list of numbers that have been added on to for each previous number. So 2 is added to 1, which creates 3, which is added to 3, which just creates 5, and so on and so forth. But you notice how 10 is not there, right? And that's because the last number is not included in this range. So again, you can specify, you can tweak what you want the list to go on. So it can go on to number 200 with increments of 5, for example. Let's see how that'll work. So this is a pretty big list. Okay. So just to recap, the range function accepts 3 arguments. The first one represents the first number. Okay, the first number is inclusive, so it'll always include this number when creating the list. Then this number represents the last number that you want to include as part of your list, but it doesn't actually include that number, so it's exclusive. And then this 5 just represents the increment number, so it shows by how much is the value when we create this list, by how much is the value of each previous term increasing. So that's what range does. So now let's just say that we have we have a variable A, and it stores the range of values from 1 through 200. Okay, with increments of 5. Let's say it does that. Now we can do the same for logic, so we can do for I in A. Okay, so what we're telling the program to do is we're taking each term in this sequence. So we're saying, so basically take 1, then apply some function, then take 6 and apply some function to it. In this case, our function is just going to be print that number. So essentially we're just taking each number in this list and we're printing some value. We're printing the value associated with it. So if we print it, okay, now notice how, remember before we had actually all these numbers enclosed within some giant list separated by commas, right? So what the for loop is, it takes each and every single, it takes I, it just represents every instance of the item in this list. It takes that item and prints it onto our console. So it'll do 1, it'll print 1, and then next line 6, then 11, then 16, and so on and so forth until we reach 196, which is our last number. Okay, so that's a really useful alternative to just typing in a bunch of numbers into your list. If you have your numbers in sequential order, then this would be a very practical idea when making your lists. So now we've done this, correct? So now what happens? We actually, I forgot to tell you guys, we actually have, just like we had if-else statements, we can actually do for-else statements. They're not called for-else loops. They're just, else is just something you can actually, you can just include in here, right? So let's see what happens when we print when we do else. Let's see what happens. So just say I'm finished. So this is what happens. Else. So if you have some function, some action that your for loop is supposed to do for each item in the list, right? Else just means that once you've performed the function that the desired function across all the numbers in your list or your data structure, when it's finally done, it'll do whatever action you put under else. So in this case, our action is printing, I'm finished. Okay. So now let's look at something called nested loops. Okay, nested loops. So we've noticed that we've taken a lot of let's just say things within things. What I mean by that is, see how when we've defined our calculator function, we've done else if else statements within functions within the context of functions. Then for the giant calculator function, where did it go? We've also yeah, this one. So now we've done we've called a function within an if else statement within a function. So just like that, we have something just like these are called nested functions, right? Functions within functions. We have something called nested loops. So what that essentially means is we're calling we are okay, let's just try to comment this. Okay. So let's just say we have some adjectives. So let's just say let's define a variable called adj. Okay. And let's create a list of adjectives. So let's just say red, oops, red, big, tasty. Okay. Something like that. Okay. And then let's define another list called fruits. This is just an example, of course. So apple, banana, cherry. Okay, so we have this, right? And now let's see what happens when we define a for loop within a for loop. And I'll tell you guys what I mean. So let's just say for a in adjective or adj in our case, which is what we're doing is we are taking every item in this list and performing some function to it. Now, if we define a for loop within a for loop, let's see what happens. For wine, fruits, print that result, green. And remember, we can print two items together by denoting it with a comma. See what happens. Oh, sorry, this is A. Okay, actually, for the sake of simplicity, I'll just say X. Why not? So we have this, and let's see what happens. So it says right here, we have red apple, red banana, red cherry, big apple, big banana, big cherry, tasty apple, tasty banana, tasty cherry. Actually, to improve on this, I might as well just concatenate these two strings together, X and Y. See what happens when we do this. We need to include. So okay, so if we can see here, notice what happens. We are defining a for loop within a for loop. So right, we have a for loop here. So ignore it, just don't worry about this for loop for now. Okay, just focus only on this first for loop. We are saying for x, so for each instance in this list, we have to do some function. This is our function, and that function states that for each y in fruits, we print that x and that y. So notice what happens. We start off with red apple, right? But then what we do is, for each y in fruits, we actually concatenate them together. So we start off with red, and start off with apple. Then we move on to red, and then banana, and then red, and then cherry, right? By cycling through fruits, all three of these fruits, and combining them with the first adjective, red, we've satisfied the first item in our condition, the function that's associated with the first item in our condition, and we tell the program to move on to big. Now, the function that must be executed is cycle through each of these items in this list and combine them to big. So we go big, so big apple, big banana, big cherry. So we've satisfied that condition. We move on to tasty. So now we go tasty apple, tasty banana, tasty cherry. So we're essentially saying for each item in this list, okay, combine every item in this list. So we're cycling through this list and saying combine it with every item in this list. So it's it's basically a double iteration. You're calling on you're calling your list and telling it to do a for loop on each item of this list. So that's a nested loop. I know this is a hard concept, so I can explain it in more depth in just a minute. Okay. And so, yeah, you know what? I'll get back to this in just a second, really quickly. We also have, if we ever have, we have a pass statement. This is something else we need to cover. Pass statement. So when we cycle through our lists, right? You don't actually have to define the list in a separate variable, and then call that list here. You don't need to do that. You can simply, if the list is short enough, you can just do this. This is a valid syntax. So you're just saying for each item in this list, do something. But if we really don't want to do anything, right? If we just want to leave this code be, maybe we want to add on to this piece of code later. Okay, but for some reason we don't really want to mess with this right now. Either we can do a comment, or there's also a convenient way of doing it, where you can just do pass. So pass, essentially what's going to happen is this is still going to execute. It won't be ignored by the Python compiler. It's just that you're telling the program for X in this list, just don't do anything. That's different from comment, because comment just actually hides the entire piece of code. In this case, as you can see, when I click run, nothing appears on the bottom. So this piece of code has actually, in fact, not run. Okay? So again, just to quickly recap everything we've gone over. So we have our for loops, and for loops perform some sort of iteration on a controlled structure. So it could be a list, okay? It could be a list of numbers or strings. It doesn't really matter the data type. But you're cycling through every single item in a list, and you're performing some function, whether it be comparing that value that the associated value to some other value. It could be that. So it could be an if else statement where we compare that item in the list to something like a comparator, using a comparator, which is equivalent to something else. Or we can also do something like this, right? Where we do a nested loop. So it could be a for loop within a for loop, where we have two sets of data, and we want to do something to each of the sets of data so as to find all possible combinations of them. Okay? So this is a really big thing when trying to do a lot of calculations in Python. So basically finding all possible combinations of each of them. So you can do a nested for loop, which essentially combines all the terms within each of the list. And then if you really don't want to do anything, you can just do a pass statement. Okay, so this was a bit of a short lesson because there's only so much you can teach in the for loops, but really one quick thing actually. Remember how I showed you guys about how in the range function it accepts a beginning and ending variable? If there's another way to do that conveniently actually is just I'll do it really quickly here. So instead of if you do this, so just say a is range of 200. What this does is Python automatically assumes that 1 is your starting number and 200, or actually technically 199 will be your ending number. Okay? If you haven't specified your starting number and you just put 200, it assumes that you're trying to create a list between 1 and 200 with increments of 1. So it looks something like 1, 2, 3, so on and so forth until 199. Okay? So now, yeah, of course, if you had a different starting term, so maybe you wanted to create a range of numbers from 100 to 200 with increments of 4, you could also do that. But if you just leave the first argument blank and just say 204, it assumes that I think you have a list from 1 through 200 in increments of 4. So it'll be like 1, then 5, then 9, and then 13, and then whatever. So that's like another shortcut you can use for a range function. And there's a lot of cool practical applications to this all. So of course, this may seem really basic for those who are more experienced, but definitely in later units, we're going to get onto some more advanced uses of these. I just want to get the basics out of the way, so it'll be more fun when we go over some more complicated stuff. So yeah, before we dismiss class, does anybody have any questions?
No, for me.
Okay, does anybody else have any questions at all?
I don't think we do.
Okay. Okay. In that case, anybody who wants to leave now can leave.